Alright, so what if we had to find the exact value of the sine of 7 pi over 6? That's not any angle that's a quadrantal angle. That's not any angle in a special right triangle. So we better graph it and see what we're working with. So we know 0 is here. We know pi is over here. And 2 pi is over here to the left. Since our denominator of our fraction is 6, we should make equivalent fractions here. So instead of pi over 1, this would be 6 pi over 6 for 1 pi. And 2 pi would be 12 pi over 6. So that should help us figure out where 7 pi over 6 should be. 7 pi over 6 is bigger than 6 pi over 6 by just a little bit, so it will be in quadrant 3. And since it's not a quadrant 1 angle, we're going to want to find the reference angle to do our work with. So remember the reference angles between where you stop and the x-axis. And so we want to subtract our two values and find out that we have pi over 6 as our reference angle. Now that should sound really familiar because that is the angle in a special right triangle. And so we can imagine that we have that special right triangle in place right there. So let's label the sides. Across from pi over 6 in the special right triangle is a 1. The hypotenuse in that triangle is the 2. And across from pi over 3 is square root of 3. Okay? And now, since we have drawn this triangle in position, we should check and see if any of the sides need to be negative. Because we have gone to the left, this square root of 3 should be negative. And because we have counted down, this 1 should be negative as well. Remember, the hypotenuse is never negative. So now that the triangle is in position, we are able to use the opposite and the hypotenuse to write down the sine. So opposite of the square root of pi over 6 is the negative 1. The hypotenuse is the 2. So we would have negative 1 over 2. End of problem. Of course, you could do sine or cosine or tangent or any of the reciprocals with the same triangle, but you only have to find the value that's asked. Let's try one more. Okay, what about the cosine of 7 pi over 4? That is not an angle in a triangle, so we'll need to draw it and locate it. 0 is here, pi is here, but we want it to have a 4 on the bottom. So if we need a 4 on the bottom, we need a 4 on the top, so that still is equivalent to 1, so 4 pi over 4. And then, of course, we have 2 pi over here, but we want that to have a 4 on the bottom also, so we would call that 8 pi over 4. Okay, so 7 pi over 4 is past 4 pi over 4. Halfway between 4 and 8 would be 6. So it's past that, but it's before you get to 8. So it would be over here in quadrant 4. So we want to find the reference angle by subtracting our angle and the nearest x-axis. So we would subtract 8 pi over 4 minus 7 pi over 4. And that would give us pi over 4. So our reference angle is pi over 4, which hopefully sounds familiar because that's one of our special right triangles. So if we fill in the sides for our special right triangle in the pi over 4 special right triangle, the hypotenuse is the square root of 2, and the other two sides are 1s. But we should consider if any of our sides need to have a negative. Remember, the hypotenuse is always positive. And then you have to check. We went to the right. So this one gets to be positive, but then we went down, so this one right here needs to be negative. Okay, And now we're in position to find the cosine. The cosine's adjacent over hypotenuse. The adjacent is this one right here. The hypotenuse, of course, is square root of 2. So that will be 1 over the square root of 2. We should rationalize that, so we'll multiply by the square root of 2 over the square root of 2, so that we can get square root squared, which turns into regular 2, and then we don't have to have a square root in the denominator anymore. Okay, hope this helps. Ask questions if you need.